We are honored to be your guests. Our next speaker is the revered Dr. Richard Gammon, one of our conference organizers. And I just have to add a personal note, because sometimes people say, oh, he's Dr. Doom, or so gloomy. But I say, embrace that. He has shared with me that his grandchildren have dubbed him Grumpy Grampy. To which I say, who wouldn't be grumpy if they knew what Richard knows about the state of our climate? Luckily for us, Richard is generous with his knowledge. Richard, welcome to the podium.
Thank you, Linda. Yes, my granddaughter did call me Grumpy Grampy. That's true. I want to start by saying my job here really is to set the stage, to begin with climate change at a global scale and relate it to the water cycle, and then try to bring that, scope that down, North America, Washington State, Pacific Northwest, and then Island County. So that's the goal. And as Catherine Hayhoe has said, climate change, talk about it. The first thing you can do is talk about it. Okay, here we go. There's a quote from IPCC. I have been called Dr. Doom, but we need to face the reality of what we've already done and grieve for what we've lost and try to protect as much as we can of what lies ahead. So if I can figure out how to advance the slides, hey, it works. So as I said, I want to begin on the global scale and then come to North America and then try to scale it down to Island County. Now, with climate predictions, the smaller spatial and temporal scale, the greater the uncertainty. So things we can say at the global scale would have to be qualified as we come to a smaller spatial scale. And down to Whidbey Island, again, we can talk about what we think might happen to our aquifer based upon use and changing climate, but there's some uncertainty with that. Here we go. So don't be scared by this. It's just a figure that says energy in equals energy out. This is not our world. Our world is actually not in balance. But this is 100% energy coming in from the sun and 100% heat going out. Heat from the atmosphere itself and heat from the surface. So those numbers all add up, 100 in, 100 in, and 100 out. And that's just to show you that some amount of energy is reflected from clouds on the way in. Some is reflected from the surface, especially white snow and ice, not so much dark colored trees. And then of the heat of the atmosphere, you can see about a third of it is radiated to space, and 2/3 of it is emitted toward the ground. And then from the ground, much of the heat of the ground, the surface, the sea, and the land, is absorbed by the atmosphere, and something goes out. But again, you can add up the numbers. Energy in equals energy out. Energy is conserved. That's not our world. We're out of balance. We're out of balance by, as if we turned the sun up 1 or 2% already. That's what we've done. So I want to make the important point that global climate change means changing global water cycle. Most of the ways in which we will experience and are experiencing climate change are through changes in the water cycle. That means droughts and floods. That means rain and storm events. That means sea level rise, which is accelerating. We'll talk about that as we come to Whidbey Island. And the danger of forest fire is increasing because hotter, drier summers increases the risk of forest fires. As we see, the fires in Canada this summer, the smoke blanketing much of the east coast of the United States. That's because the wind was blowing from the west to east, but it doesn't always happen. Sometimes the smoke from our forest fires and Canadian fires can come the other way, can come to us, as you'll see. The water cycle, let's look at that for a minute. So, starting at the top, oops, sorry. Go back. You have evaporation, from the land and from water. We live on a water planet, right? Most of the earth is water, is ocean. And transpiration from the plants, that cools us. That's why we sweat, right? If you can't sweat, then you get hot. So that energy goes up, energy is conserved. And when it condenses, when rainfall occurs, then energy is released in that condensation. And coming down as snow or rain, and as runoff, and you see infiltration. Oops, sorry. Oh no! I'm trying to find the pointer. Oh.
The green line.
Oh, yeah, thank you. Groundwater and uptake of groundwater by the plants. So this is the cycle. And water is essentially conserved. Water doesn't escape to space, and energy is conserved. But what we know now is that total water vapor is increasing. Why is it increasing in the atmosphere? Because the atmosphere, warmer air can hold more water. And so there will be more evaporation from soils and more evaporation from water. In a sense, the total amount of water in the Earth's atmosphere is set by the temperature of the ocean, and secondarily by evaporation from soils. Now, this is a law of physics down here that for each 1 degree of warming, atmosphere can hold 7% more water. It's called the Clausius-Clapeyron relation. And that's why the atmosphere is wanting to take more moisture from the surface, because as the atmosphere warms, it can hold more water. This is the only slide that has a lot of words. Because some people actually think it's true that CO2, that water vapor is causing global warming. No, it's not. Water vapor is a consequence of global warming. These are words from NASA. Some people mistakenly believe that water vapor is the main driver. But increasing water vapor doesn't cause global warming, it is a consequence of it. Increased water vapor in the atmosphere amplifies the warming that is created by other greenhouse gases, primarily CO2, methane, nitrous oxide. It works like this. As the greenhouse gas increases, Earth's temperature rises in response. This increasing evaporation from both water and land, warmer air holds more moisture, its concentration of water vapor increases. The water vapor then absorbs heat radiated from Earth, prevents it from escaping to space. This further warms the atmosphere, resulting in even more water vapor in the atmosphere. Positive feedback, amplifier, positive feedback loop. This effect more than doubles the warming which would have happened due to CO2 alone. So again, CO2 is the driver, but the amplification due to water vapor more than doubles the CO2 effect. I couldn't quite get this slide to work right. It shows the emissions by country from 1850 onward. And you can see the US emissions here peaking and now starting down. We started down about 15 years ago. Europe started down about 30 years ago. And today, in today's emissions, China is about a quarter of the total emissions today, and we're less. But what matters is the integrated amount. The warming that we experience and will experience is directly proportional to the total integrated cumulative amount of CO2 emissions. In that, we are guilty, guilty, guilty. We're number one. We've done the most to cause warming, not China. Although China has more emissions today than we do. And you can see the rest of the world, India is just beginning. So the emissions are about 35 to 40 billion tons CO2 today. And that's not counting the methane and the other greenhouse gases. This is the carbon dioxide curve, the famous Dave Keeling curve, which he started in 1958. He had convinced the US government that he could go to an active volcano and make meaningful measurements of carbon dioxide. He did. And Dave's gone now. But his son, Ralph Keeling, continues the measurements for Scripps. And side by side with the Scripps measurement is the US government measurement by NOAA. I was responsible for this network in the early 1980s. And when I was responsible for this network, I went to Mauna Loa with Dave Keeling, and the numbers were 342, and it was going up 1 per year, 1 part per million per year. The numbers today is 425, and it's going up 3 parts per million per year. If you say, oh, this is the most important geophysical measurement in the world, of anything we do. This is the most important measurement. This is globally representative. If you say, well, we got to stop the increase. What if we had constant emissions? If you had constant emissions, what would this curve look like? It'd be straight. If you had decreasing emissions, this curve would be bending over. And if you had zero emissions, net zero by 2050, this curve would be flat. And then it starts down. But does it go down fast? How long does it take to get that CO2 back out? Hundreds and thousands of years, unless we mechanically remove, not just tree planting is important, but direct mechanical removal of CO2, I think we're going to have to do. Anyway, when I look at this curve, I think about 40 years back when I ran the network, and where is it now, and where is it going? Have we turned the corner? Is this thing leveling off yet? No, not yet, not yet. And this is there are many versions of this. This is Jim Hansen's version of the global temperature. Notice that since about 1970, in the linear curve, the green line, that's the linear rate of increase of CO2, of temperature. And where are we now? We're about 1.2, 1.1, and especially in super El Nino years, we're just in another El Nino year this year, after 3 years of La Nina, the other phase of the cycle. And if we have accelerated warming, as Hansen thinks we will, we can easily go beyond 1.5 degrees C. That's the limit that the Paris Accord says we should try to stay under. 2.0, certainly stay under that. Do I think we have a shot at that? No, I don't. I think we're going to blow right through 1.5 in this decade, and I think we're going to go past 2.0 by the middle of the century. I think we're going to be in a much worse situation. These are the pathways for possible warming. If we have a low emission pathway, we might have emissions stopping now and CO2 not going much above 450 or 500. 550 is double CO2. The natural level is 270. So 540, 550 would be double CO2 and then starting down. These are representative concentration pathways, low emission, modest emissions, and high emission. The high emission pathway, you can see that we blow right by 500 ppm and we head up toward, is there enough coal, oil, and natural gas to go up here? Much, much higher. What sort of warming would that be? Oops. So these are the warmings associated with those emission pathways. Again, the low emission pathway, we might stop at 1.5 and start down, but most of the others are still bending up. And the high emission pathways takes us above 2 degrees centigrade, 4 degrees Fahrenheit, if you like Fahrenheit, by 2100. So in the lifetime of children born today, the world would be very different. At 2 degrees of warming, if it stays at 2 degrees, there will be no ice. There'll be no ice in Antarctica, there'll be no ice in Greenland, and sea level will be 200 feet higher. 200 feet higher. The last time the Earth was 2 degrees warmer than today, there was no ice at the poles. And there will be no coral reefs. You can tell your grandchildren, your great-grandchildren, we used to snorkel and see the fish. Sorry, we'll never see that. No coral reefs if the warming is more than 2 degrees. This is the kind of pictures that we see for warming of 1, 1.5, 2, 4 degrees C is not out of the question. If we're lucky, we can stop at 2. If we ignore this problem, we could go on. Look at these pictures. They all have the same thing. The warming is greater at high latitude than near the equator. The warming is greater on land than over the ocean. Not shown here. The warming is greater in winter than in summer. The warming is greater at night than during the day. All observed. We already see that. That's the pattern of global warming. The warming in the Arctic is 3 or 4 times faster than a warming near the equator. How am I doing for time? All right. He's going to keep me on time. The World Meteorological Organization says there's a pretty good chance, better than 50-50, we're going to blow right through 1.5 in the next 5 years. Not stay there, but 1 year is going to be above 1.5. That's where the island nations of the Pacific said, stop at 2 and aim for 1.5. We're not going to make that. We're not going to make that. So looking at the U.S. scale now, that was sort of global scale. I'm showing a number of pictures now. And so look at the U.S. for these different types of scenarios, but then always have an eye on the Pacific Northwest, especially Puget Sound region, Cascadia, west of the Cascade Crest. Here are our emissions. And yes, we have started down. The U.S. started down about 10 to 15 years ago. We're not down to half yet. We're not down to zero, but we have peaked and we're starting down, which is good. Europe started down long before we did. But the rest of the world, tell India, tell China not to build coal plants. That's a tough sell. Here's the actual temperature record for the U.S. Flat after World War II, and then rising quite abruptly after 1970. Those fires in Canadian forests, look at the temperature anomalies in May. 12 degrees C, 24 degrees Fahrenheit above normal. No wonder their forests caught fire and sent the smoke eastward. But it wasn't always like that. We've had, so this is earlier in May, there are a lot of pictures of smoke going eastern half of the United States in the month of May and the beginning of June. But a couple of years ago, it came the other way. Remember this? There's a fire in eastern Washington with smoke heading to Seattle and Puget Sound, and fire near Bend heading over Portland. Depends which way the wind blows, right? Most of the impacts of smoke on fire on human health are not in the regions where the fires occur. It's in other counties, in other states, in other countries. This is an average, just a 30-year average, the last 30 years of rainfall in the U.S. versus the 20th century. And you can see already in this picture the developing drought in the western and southwestern United States. But, hey, not here. We had more rainfall. In the eastern United States, on average, had another 10% above their average rainfall for the year. This is, now take an extreme scenario. This is a high emission scenario. I hope we don't follow this, but if we did, this is an estimate of those places in the U.S. that are going to have extreme temperature. Not where we live. Not in Maine. All these people that are moving to Arizona and Florida, where are they going to go? Where are they going to go when they can't buy insurance for their home in California? State Farm just canceled all insurance policies for homeowners in California. Where are they going to go? How about wildfire danger? Hey, not where we live. Not so much anyway. Not so much. How about corn and soy? Not going to grow that in Texas anymore. Where's it going to go? So the green colors mean not decline, increasing yield. All this green is places we're going to do better with corn and soy. Corn growing areas are going to move north. How about sea level rise? So in purple, this is the percentage of property which is going to be underwater at high tide, all around the United States, especially south and southeastern, but also California. And look at us. Some percentage, a few percent of our property, including here on Whidbey Island, will be underwater at the mean high tide. Now, that depends upon whether we have 2 feet or 10 feet of sea level rise, right? In California, they are saying plan for 6 to 10 feet. Don't plan for 2 feet. Plan for 6 feet. So if your well, your septic tank, or your country cottage is at the high tide line, your grandchildren will not have it. They will not. It'll be underwater. So economic damage from climate change, and again, green here means economic gain, not damage. So these people are all going to suffer worse, and where will they go? Well, they'll go north. Maybe they'll come here. Maybe they'll come here. Okay, here's our emission scenario, and I hope that we do this. We started down about 2005, and hopefully we'll knock it in half by 2030, and then we'll come all the way down to zero, net zero by 2050 in the lifetime of children born today. In fact, before teenagers, high school graduates now reach middle age. We've got to reach net zero. I don't have a lot of slides for the local area, Whidbey Island area, but I would encourage you to look at the Climate Impacts Group at the University of Washington, which has a special application that lets you look county by county at climate change impacts. I'm sorry I don't have slides to show you for that, but I'll just say the things that I worry about for Island County are soil moisture and drought, sea level rise, sea level rise, increasing fire danger. We haven't had a really big fire on Whidbey Island for a long time, but with hotter, drier summers, we have to be much more careful with fire. People are going to move here. People are moving here. People have moved here. So as other parts of the U.S. become less hospitable, people will move north and move northwest. And so this means whatever our aquifer capacity is, and you're going to learn more about that later today from other speakers, if we have increasing demand on our aquifer, will there be enough water? Basically, in South Whidbey anyway, we live on well water. I think at the Navy base and in Oak Harbor, there's some piped water from Skagit, right? But not down here. So we have to learn to pretend like we're in New Mexico, be more cautious in our use of water. I think I'm about done. This is a recent report on sea level rise in Washington State by the Climate Impacts Group, and a report led by Ian Miller. Again, he's a great speaker. I think that he lowballs it. All of the estimates of sea level rise in this time and since this time have accelerated sea level rise. So I think his numbers of, say, 1.5 feet or 2 feet are too low. I think we're going to have 3 feet or more by 2050, and we may have 6 or 8 feet by 2100. What should I do? If you're not Dr. New, at the end of the talk, you have to say something positive, right? Well, use water and energy more efficiently. Reduce waste, recycle, compost, all those things. When we had the Taming Bigfoot exercise a few years ago, I realized that I was putting my green kitchen scraps in the garbage. And I need to put it in my yard. So I started composting. So electrify your home and your transportation as much as you can, in whatever way you can. Not everybody's going to go out and buy a Tesla. Not right away. Restore and protect existing forests, wetlands, coastal marshes on your property. And work with other local environmental groups like Sound Water Stewards, WEEN, Whidbey Camino Land Trust. All these groups are working to protect and restore the beauty of our island. Be careful with fire. Be very, very careful with fire. And any building, new building, or septic tanks, aquifers, wells, move back from the high tide line. That cottage at the high tide line is not sustainable. It won't be there for your grandchildren. Move back. And measure your personal carbon footprint, your family carbon footprint, and then work to reduce it. And then the most important thing, since you're here this morning, is to stay. Stay for us for the afternoon and come dive deeper, learn more about, in the workshops this afternoon, about individual topics related to water on Whidbey Island. Thank you very much.
Thank you so much, Richard, for that informative and hopeful or actionable information. But 8 feet, wow, above the mean high tide line, that's